Welcome, everybody. This is our first lightning round we got 4 speakers. I'm very excited with people talking to us from the future. That's what's most exciting about this. Maybe they introduce us to new stuff that we haven't heard about in the past. So today we're gonna have a series of lightning rounds, short talks. We'll do questions after each of these talks, and to introduce our incredible speakers, we have Olga, who's going to be talking about something called From Emails to Datasets, Serverless Data Pipeline. Then we have Danny Chan. He's going to talk about serverless idempotency and atomic counters. Michael Walmsley, I struggle with your name, Michael.
Everyone does.
Is logging enough? And then Stephen is running late. He's going to join us, and he's going to talk to us about the 1 billion row challenge, serverless edition. So to not keep everybody waiting, we're going to kick it off, and we're going to start with our first speaker, Olga.
Imagine receiving hundreds of emails per day with attachments that you need to process. Each of them has a deadline and can cause some manual processing errors. And now, think of a world where AWS turns this mess into order by receiving, processing, and publishing data where it's needed to be. Hi everyone, my name is Olga. I'm a data engineer for local property portal similar to Zillow called REA Group. I'm also AWS community builder and co-host of the Women in Cloud meetup. And today we're going to talk about serverless data pipeline and in particular cases where we receive data via email. And because it's a lightning talk, this is the only diagram we're going to go through today. And to help us with that, we need to have an example. Imagine we have a friend, Jeff. Jeff's birthday is coming up, and we got a task to organize his birthday party, plan everything, invite his friends, book venues. And Jeff is sociable, but also very organized guy. He has Excel spreadsheet where he has all the people's details, the dietary requirements, entertainment options, everything. And we asked Jeff to send us an email with that iconic list. And to receive that email, whether it comes to me, to Michael, to Danny, we can set up SES rule, this subdomain. You can see that everything sent to email@yourdomain.com is going to trigger our pipeline. Once the pipeline is configured, we receive the email, we can set up actions. Actions could be to trigger Lambda directly, or maybe save email in S3 bucket. But if you're familiar with emails, the original email format is not very readable. It looks like a binary blob, and in order for us to separate attachment, we need to use Lambda. And that's what we do here. We save it in S3, then through SNS, we trigger Lambda function. Lambda function is going to process this email and extract attachment here. Looks easy, we have the list, but it's not that easy because Jeff is concerned about his guest's privacy. He set up a password, and he could go even further. He could encrypt it, he could make it complicated to retrieve the file, but at the moment, let's assume it's just password. That's why we need this second system, content processor. Content processor is going to get triggered, take the file, remove the password, and drop it for our next system called file ingester. Now we have the list, but we don't want to manually go through all the records. We want to split them. We want to treat them as individual contexts. And that's why through SQS and Lambda, we're going to process it and split it by records. Now you can send messages to people, you can individually book activities, venues, food, record by record. Seems like the party is done. You probably noticed that through whole our pipeline, we have a combination of Lambda and SQS, and it's not coincidence. The reason why we do it is because we want to make Lambda more fault tolerant, meaning that if it can't succeed from first attempt, we can try again and again and again. And we have 3 retries. If it doesn't work still, then unfortunately we can't process the file. and we can't invite those people. But imagine if the issue is caused by just one person, say Lady Jessica, she didn't have a phone number, but phone number it's a mandatory field. What we can do, we can have a DynamoDB table here and register exception, but keep that record. So the rest of the people get notified. We organize a party, Jeff is happy, friends are happy, they took a lot of photos. Now it's the time to collect the photos. What can we do? We can potentially build another system, or we can reuse what we have and receive images via email automation service. If Jeff's friends want to get notified when photo is uploaded, they could subscribe to our SNS. It's called fan-out pattern. And the same is ingester. We don't have to ingest records. We could ingest food options or recipes. And on top of it all, it only costs us money when we use it, meaning that when there is no parties, there is nothing to receive or process, we don't pay anything. And if you're familiar with Lambda function prices, which you should be since you're here, you know that it's incredibly cheap. I wanted to put a disclaimer that at work, we don't really deal with birthday parties. We deal with serious data sets and very complicated ways to encrypt the data, but the concepts are the same. First, reusable components over large size single-purpose systems. Second, always think about being fault tolerant, like in our case when we add SQS in front of Lambda, and the fact that it's event-driven and cheap because it's serverless. On this note, I want to finish this talk and I'm open for questions.
Good. That was simple and straight to the point. Question for me, it's you had the SQS queue and things dropping into dead letter queue, right?
Yes.
How would you, when something falls in that dead letter queue, what's your processing? What's your thought on how to get them out of there?
It would be an alarm. So in here, so it would be an alarm triggered when you have more than 0 messages, and then somebody would have to manually have a look and see what is there and what caused the issue.
Cool, cool. And is in the real scenarios, can you talk about, I don't know if you're free to talk about, not the birthday parties, but what you use it for in the real life?
Using for processing data sets that come from external party providers. Via property portal, say we have location data, right? Some like longitude, latitude, something like that. If it's a big file, it would come via email, would be encrypted. Yeah, you could process something like that.
Cool. Let me check the comments, see if there's any other questions. I don't see any. Thanks a lot, Olga. This was great. It's very useful. I think I'll want to try something like this out and play around with it. So thank you. So now next in line, we have Danny Chan talking about serverless idempotency and atomic counters.
Yeah, hello.
Great. You go.
Okay, let's start. So if we want to know how to build queue-based architecture, start async communication, and improve reliability, this session is totally for you. I'm Danny Chan. Today we will discover what is idempotency, what is atomic counter, diving into the mechanism, and we will discuss why is message ordering critical. First question, how to deal with received duplicate message. Idempotent action produce same result regardless of repeating. Repeating actions always get the same results, so it could prevent the duplicate data error and improve reliability. Let's see the underlying mechanism. First, on that DynamoDB, we will set the condition expression. Attribute not exists to ID. Let's see the examples. DynamoDB store the record. The record contains payload hash. Before execution, we check the DynamoDB for existing record. We use attribute not exists to prevent duplication. If the record exists, subsequent jobs skip processing. It ensures requests are handled idempotently. It provides reliable process of event, and the same payload executes only once. So why release idempotency? Since SQS delivery message at least one by default. The message may be delivered multiple times. Application must handle duplicate safely, so you need idempotent approach. Messages are processed only once with retry occur. It prevents error from duplicate action. And for finally, idempotency is request for queue-based message for queue-based architecture. It improves the reliability. Let's see the example. You can imagine the Lambda is unavailable. SQS do the first retry and second retry, and finally, the message stored on deleted queue. After that, we fix the issue. Lambda is okay now, and we send the message from deleted queue and finish the execution. So you can see idempotency is ensure the same outcome on repeating operation. Let's dive into another topic, atomic counter. Here, I would like to say why ordering message is critical. Here is the user behavior tracking for funnel. For the first action, user add the product to shopping cart and then check out the product. And you can expect shopping cart is the critical feature. However, if we on the wrong ordering, we will expect add the product to shopping cart without further action. And we will expect the shopping cart is not critical feature. User prefer directly check out. This is bad, this is not good. So here, atomic counter allow increment a number attribute. It allow update are all or nothing. Ensure items stay accurate. Let's dive into underlying mechanism, how to apply atomic counter to DynamoDB. First, DynamoDB automatically perform counter operation. Conditional while update expression set to +1. It ensures counter consistency. And it also prevent inconsistency during concurrent update. You can see the example. The operations always return the last value. Here is the full picture of how to use atomic counter to process ordering message. First, we store message on DynamoDB and add the counter attribute to track the ordering. And then we increment the counter on message update. After that, on database streaming, we notify the state changing. The outgoing message will always include the ordering counter. Counter is set to +1 and then echo counter set to +2. Okay, the atomic counter ensures consistent ordering. It maintains the ordering, even the concurrent access. Okay, let's see. Lambda is the pay-as-you-go service. It could easy to help you to maintain your system because it's easy to add more batch support jobs. Finally, you can monitor the data queue and easily to handle the rerun error message to finish all the job. Let's see the key takeaway. First, idempotency improves reliability. It handles duplicate safely. It facilitates asynchronous communication, and it is the critical for queue-based architecture. And finally, we discuss atomic counter. It helps you to ordering the message, and it also provides you the consistencies during the concurrent processing. Okay. Thank you so much. I'm Danny Chan.
Great stuff. I've never actually done the atomic counter. So a question there is, if you get, so you're adding a number to the DynamoDB item, right, to know that message and get them in order, right?
Yeah.
How would you handle the situation where you get, let's say you get the counter 3 before you got the message with the 2? Would you queue them up or until it gets there, or what's your thought?
Okay, you can expect I modify the message to another system because another system doesn't know the ordering. So I will add the counter to the message. So you can reveal the message. Oh, here is 1, and then you receive the message with the counter is 3. You expect here is missing. It still have the second message you need to handle first. So you will store the message with counter 3 to the SQS or database, and then keep waiting. And then after we receive the message with counter 2, processing it, finish it, and retrieve the message with counter 3, and then keep going. It could keep you process the message with ordering.
Cool. Awesome. There's a question from Danielle. There you go. Have you used the Lambda Power Tools idempotency feature? If yes, how do you like it?
No, not yet. I will keep trying it.
Yeah, it's something that's in my list to try it, but it should simplify, at least at the Lambda level, handling idempotency, and I believe it handles the kind of saving the idempotency key or whatever it's using there, and it takes care of saving it in DynamoDB, etc. So something interesting to try out. I believe it's on both Python and the TypeScript one. I don't know on the rest of the Lambda Power Tools. Good question.
I will try it. Yeah.
Have you done any type of idempotency like at the API gateway level or at other places, not just at the Lambda or DynamoDB level?
I mainly focus on serverless now, so I only adopt idempotency and on my DynamoDB, on my serverless Lambda function first. Yeah.
Cool. Should I try? So there's a question by Jonathan. I don't know if should I try to make everything idempotent?
No, you don't really need to do this because I give the example is the funnel analytic, and it's not everything you need to keep ordering, especially with you. How could I say that? Is processing the state, is processing the record. You only need to load the final result of the record. You don't need the ordering.
Okay. Cool. Another place where I recommend idempotency, and I'll mention here, is with if you're using step functions, with the whole redrive features that you get.
Step
making
function.
things idempotent there, so you can just restart the execution where it left and all that. So yeah, there's a lot of value in many places for idempotency. And the big one, the big one is the one you mentioned around SQS. And again, if it falls on a DLQ, and then you be able to reprocess it because it's idempotent, you can just re-trigger the message, and it's all good. So good stuff.
Yeah, thank you.
Great. I don't see any other questions. So thanks a lot, Danny. Great presentation. So next up, we have Michael, I'll say it correctly, Walmsley, talking to us about if logging is enough.
Hey, how you going? So I'm sporting the Serverless Days background today because next week in Sydney and Auckland, Serverless Days is running. So if you're in ANZ, you should get your tickets and get down there.
Nice.
Welcome. Today, I want to thank Midjourney for my Illuminati observability triangle, showing up the standard things we have in observability of metrics, traces, logs, the things that we are all used to. And today, I'm going to talk about, having some say, is logging enough? Interesting question. Let's delve into that. Let's dig into that. Who am I? I'm a lead technology architect at Accenture. I work in a global asset team where I build products to accelerate the work done by consulting services. So I don't do consulting, but I work for a consulting company. I'm an AWS Serverless hero since July 2023. And I've been building software for over 30 years. Feels like a really long time. Random fact about me, Alan's not here today, but like Alan, I too have chickens in my backyard, but I don't live on a farm. And something you might not know about me, or some people do know, is that I actually have a beehive in my backyard, hence the bees there on the right-hand side in the diagram. So observability, developers, we need to think about a lot of different things. We need to think about a logging library, and we need to use that in our code. We need to think about metrics, and we need to use that in our code. And then we've got to add in a tracing library, and we've got to think about that as well. It's a lot for developers to really think about. There's a lot of different things we need to deal with. There's a lot, and as we all know, the common developer, and a lot of people in this community don't consider common developers, but the average developer is not the best at thinking about all of these things all the time. So we're developing, we write our logs. They take minutes from our logging library to get anywhere in the cloud. We know that, right? There's delays in the cloud. Everything's asynchronous, and they cost money. We write metrics. We through our metrics libraries, and if we use metrics, if we use the metric API in AWS, well, that costs us for every time we make an API call potentially. But the good thing is with metrics is we don't need to use the API. We can use the embedded metric format, which means it's going out through CloudWatch, which costs money. We then, at the end of the day, we click and we follow through and we list out our metrics. They land in our dashboards, and we get charged again for having metrics in the dashboards as well. So all these things add up and cost money. Then we have traces. And quite frankly, does anyone really use AWS X-Ray? Do people get value out of it? I mean, I love it. I work in government. I do a lot of government work, do a bit of government serverless work, and it's a very restricted environment. So using external parties is not allowed. So I love it. Seems like a good addition. It's a real tick in the box for going, well, we can trace everything. But they also cost money. And after we've done all these things, and we've logged, we've sent our metrics out, we're writing our metrics, we're sending our traces, we then somehow have to build that triangle and try and bring all these things together in one place so that we can actually work out and observe what's going on. And that's the challenge, the observability challenge that we have. Fortunately, we have, how do we reconcile all of those things? Well, usually we export everything out of our cloud to a third-party provider, like Datadog. Maybe people use Honeycomb. Baseline's quite popular in the community, in the serverless community. Lumigo, where the new kids, the first kids on the block years ago, as a new serverless startup. But and then we've got a whole gambit of other providers in the space. We use these tools. We use these tools because we need to be able to bring all those things together and make sense of them. And they all cost money. Not only that, they all cost money. We pay per use potentially, but we also have to pay to send all our data out to all of those providers. So at the end of the day, if it's one thing I've learned building in the cloud, it's moving data around at scale is hard and expensive. So why do we do it? Why do we do it? Observability can be an expensive business. But is there a better way? That's the thinking. That's what today is all about. What about if we combined all of our logs, all of our traces, all the metrics into one thing and send that one thing outward? So our developers are only thinking about one thing, and we just use logs. That's the question. Is logging enough? Can logging be enough? Is the question that I want to ask all of you today. I'm not the first person to say this. Stripe said this with canonical log lines back in 2019. They do all key telemetry is in one place, simple to query. They can refactor that. They put it in such a way that it can be easily parsed, and you can easily transform it for different use cases. You can search it, you can filter it. It's powerful. So I'm not the only one saying this. Honeycomb said this in 2021. Wide events. They've got a really good blog article. There's some links and references in the back of my presentation. You know, Honeycomb talk about wide events, and really they're simpler. It's just a single event with lots of fields, lots of attributes. It's all your data in one place. So for every transaction or every request for a service, you have all your data in one place, which is powerful. So using wide events means less data going out, one request per service, maybe two requests per service. You can choose, and it's up to you to make up your minds about how you use this, but it can be an effective way of trying to reduce your egress fees of data going out across the cloud. I read something earlier this year with Serverless DNA. I wrote a tool called WideLogger and released that earlier this year. It's an NPM package. And it's why I made WideLogger, is because in my experience with doing logging in government environments where I can't export out to third-party providers and bring all those metrics, traces, logs together, I really started developing my own techniques of logging, where I logged everything into a log message and utilized the log messages to calculate my metrics. So WideLogger is the culmination of my experience of doing that work over the last few years. And it's very much in the same vein as Honeycomb's wide events. It's pretty much the same thing. Also, canonical logs, you could argue it's like canonical logs. The beauty of it is it's simple to use. Here's an example, some example code of using my WideLogger. It's really simple. By default, you just instantiate the WideLogger. You add stuff to it, fields to it. You can add a new field. You can overwrite fields. Doesn't care. It's just a container. It's just collecting data. And at the end, when you finish your processing, you just need to flush that out, which makes it really nice and simple. By default, it goes out by JSON, which is great. You can bring your own formatter. So I've provided a formatting agent in here, so you can actually bring your own. I provided by default a key formatter, so a key value formatter, very much like a canonical log. The example's down the bottom. Or you can bring your own. You can write your own. So it gives you the ability to actually reformat your logs. If you've got particular tools in your tool chain that process data in a particular way, you can format to that, which is great. And I've introduced MIDI. I've also added MIDI support, which is powerful. One of the things that comes with MIDI support is the fact that we know from MIDI we have the Lambda context. So it actually allows the injection of the Lambda context. And it does this using the standard AWS Lambda Power Tools TypeScript format. So if you've already got observability tools that are used to this format, then the WideLogger can fit into your environment. Now, this is not something that replaces logging. It doesn't replace metrics. It doesn't replace traces. It's additional. Or it's not additional. Maybe it's the only thing. And that's the thing you need to decide. That's the thing that I'm calling out today, is that we really should look at the way we approach our logging. We should really rethink. I think the way we're moving and the way things are moving in the environment, we need to rethink what we do and not just do what we've always done before. You heard Dr. Werner Vogel say that last year at reInvent. Just don't keep doing the same things we've been doing. So the call out today is to revisit your logging strategy. Really think about what you want to write out. Do you need all those log lines? All those log lines cost money. Consider wide events. Really consider it. Calculate your metrics from your wide log. So all your attributes can go into your wide events. And from there, you can calculate all of the metrics. The beauty of this is even if a transaction goes through 3 or 4 microservices or lambdas, lambda functions that log separately, you can bring those together. You should have correlation IDs going across to link those logs together, and you can link those together. You can get them all in very, very quickly. So you can get a very quick snapshot of the way things are going, and that's really powerful. Don't push your data to 3 places. Just use one. That's what I'm calling for. So thank you very much. Some references. Honeycomb blog, how to use a single wide event to its fullest extent, is a really good read, an interesting read. On the Stripe blog, fast and flexible observability with canonical log lines is also a really good read. And of course, there's a link there to my Serverless DNA WideLogger, and a little end note there from the Mr. Frugal architect there of be frugal with your logs, is what I say. Thank you very much.
Good stuff. That's very interesting. We do have a few questions. One very important one from Jonathan. Are bees or chickens easier to raise?
I would say bees are actually easier to raise than chickens. Bees look after themselves mostly. All you do, you're a caretaker with bees. With chickens, I've got chickens at the moment. I've got 3 chickens at the moment that won't roost in the hen house. So every night after dark, I've got to go out and stick them in the hen house because they haven't learnt that yet. And it's been like 4 days. Bees just know. They teach themselves, right?
Yeah, I don't like bees. Do you have like the whole? Do you have like the whole suit and stuff for the bees?
Yeah, absolutely. You have to. Yeah, you do. I do. But it's beautiful, right? I earlier this year I extracted 20 kilos of honey. Wow. And it's really good. It's like real raw honey. It's like.
So I don't know if Alan already knew you did the bee stuff. I know he's wanted to have bees at his place, so he might contact you now in regards to that.
I might have to talk to you about it. Yeah.
Cool. So there's a question by Ola. Can it be too much logging?
Well, that's an interesting question, right? I actually think from a production perspective, you should be frugal. And I think that it comes down to in production at scale, I think that's where you need to be frugal. And I think when I talk about using wide logs or using wide events to do your logging, really jamming all those important attributes, all those business attributes, those key things you want to track into that message is powerful because it goes to one thing. And the beauty of that is also the fact that when you're logging a single event like that, it's not, as you introduce more services into your environment, your logging capacity is not going to scale logarithmically. It's not going to be exponential in nature. So I think it can be too much logging. In the development environment, I think use debug logs, right? Use that to your advantage to understand what's going on. But again, the beauty of having the wide logs is it's really easy to search. You can easily stream these to one place. You actually stream them all into a common place and have that place as the place you look at to actually see what's going on in your system. So you don't have to do complex aggregation. You don't need to buy an aggregation service. You don't necessarily need to. CloudWatch Insights is awesome at searching these. And that's what I've used in these government environments. I mean, Andreas, you do work a little bit in government as well. It's very regulated. There's the external connections are hard. Everything's hard. It's like 10 times harder. And this opinion is born out of my experience over the last few years working with restricted environments a lot. But yeah, I think it can. I think logging can be too much. But is it enough? I think so.
I'd rather have a bit more than less, right, to help you troubleshoot your stuff.
I've been doing software for a long time. I came from the old Unix days, right, where less is more. Right, less was written because more was too much, and less was much better. So less is always more.
Yeah, interesting.
Showing my age now.
I'm browsing here. Whenever I try, pop that one in, Jonathan. Whenever I try to take a bee eggs, they get really angry. Much easier taking the chicken's eggs. Is that true, Michael?
I don't think you can really take a bee egg. They're in a frame. They're in the middle of the hive. So yeah,
it's pretty tough.
Yeah, easy to take chicken eggs for sure. I agree. But look, really, I think today's talk is more about really go out and think about what you're logging, think about what you're doing, think about your strategy, right?
Yeah. So
can it be enough? I think so.
Yeah. And Jonathan's asking if there's a tool you recommend to use in the government sector. I mean, you kind of mentioned CloudWatch and Log Insights, but do you have any other one?
I go pure native. I like to use pure native cloud all the time in those environments because it's simpler. There's things you can do. I mean, CloudWatch Insights is awesome, right? I'm also working within Accenture. We build a lot of internal tools. We do a lot of monitoring. So I work in the AOps, doing a lot of AOps kind of stuff across huge landscapes of servers. So I do that in a serverless way, which is awesome. But that's interesting. And so we build a lot of tools. It becomes, in working for a company the size of Accenture, it becomes expensive to actually roll out third-party products across, 2,000, 3,000 clients. And we're talking large landscapes, volumes, huge enterprises, right? So that's why there's a mentality of, I struggled. I've been there for 3 years. I'm struggling with this mentality of we have to build it. I'm like, why? Because it's different. It's a different mindset.
With that many clients, right? Like you said, sending it yet to another tool, duplicating costs somewhat, it can be prohibitive. And purchasing a new product in a big company is also
I've tried.
It has its challenges.
I've worked really hard to get to utilize some really good services out there, and it's not easy. I hear, but yeah.
So David's asking, how does your offering compare to Power Tool metrics and all that it's offered by just the Power Tools libraries?
That's a really good question, right? Because you can use, you probably could use metrics from Power Tools in exactly the same way. I know, David, I've read on Discord, you actually use it in this particular way. So it's almost analogous, right? But the different, and just thinking about this, it probably is very similar, except you will actually be creating metrics. So you will be paying again for those metrics to actually hit. So you actually are tracking metrics and dimensions, which you can get in exactly the same way from wide events. So I think it's very analogous, to be honest, except that I think that the logs allows a little more freedom, I guess, and not being locked into creating metrics. Yeah, I agree. I do agree. They are very, very similar. Good question.
Yeah. And then there's one by Dan. Is it good to centralize logging from multiple accounts? And I know CloudWatch recently, and maybe last year, right? They added the ability to capture cross-account logs and centralize your dashboards and all that.
I think so. I think if you work in any enterprise realm, centralizing logging is super important from a number of different aspects, from a security aspect as well as an application monitoring aspect, because you want your alerting to happen in one place, you want your monitoring to happen in one place, you want your observability tool chain to not have to look at 10,000 things, just one thing. But of course, these things add delay, which is the thing that really irks me. And sort of, there's ways around that. And there are ways around that, I'm sure. People have thought about it. But, but definitely, I think centralizing logging from multiple accounts into one place is important, providing they're associated and related from your service perspective. If you've got multiple accounts and some of the different products that are not related, you need to really think about, well, do you need those centralized? I think if you've got multiple accounts for one application or platform, then yes, I think you should. I think that becomes a strategy thing. Do you really need to think about, well, what you should do? But centralizing, I don't think there's anything, again, there's no harm in centralizing. And which means it's easy. It's one thing to centralize if you're doing logging only. Just saying.
Would it be because it's not necessarily physically centralizing the data for your logs, but it's centralizing the access to the logs, right? So it's not.
Yeah. I really struggle with like I said earlier, I really struggle with moving data around the cloud and centralizing logging. So yes, that's a good idea, but now we're moving data around the cloud, which we know is hard, and we know costs if you're going across regions or other things that can potentially cost. So I think we need, and I see this with in the current world with generative AI. I think we need to really look at that and go, do we need to move data around so much? Because now we've gone back to everything has to be one place for generative AI, and so it's like, no.
Yeah.
Beautiful. Thank you.
Cool. Well, really appreciate your time, Michael. This was a good talk. And
thank you.
I played around with metrics, not so much traces. You mentioned it there, but kind of reusing your logs and using that is a very interesting approach, and I'll definitely
And you
play
can,
around with that.
and with wide logging, you can get all three. You get your metrics and your tracing because you link them together with. And interesting thing I'm playing with at the moment is even if you don't have X-ray turned on, with Power Tools Logger, you actually get the X-ray trace ID. Just saying, actually exists. Interesting.
So it's
I'm looking
there
at how,
even
looking
if
at
you
how that
don't turn on
propagates
X-ray. Is that
yeah. With tracing not turned on, it just turns. It's there all the time. So I don't know how far it goes through the stack, but I'm playing with that at the moment to
Cool.
see how far that goes through the stack because that's interesting, right?
That would be interesting, and know what you end up with there. See how far it goes. Cool. Well, thanks a lot, Michael. Happy to have you here. So now, last but not least, we have Stephen. I always struggle with Stephen.
Yep, just Stephen.
To talk to us about the 1 billion row challenge, serverless edition. This sounds exciting, so I'll let you to it. Thanks.
No worries. Yeah, look, so I want to give people a bit of context for this because a lot of people might not have actually heard of this before, this whole concept of a 1 billion row challenge, and why I decided it would be kind of a crackpot idea to throw serverless at this idea. So this is a work in progress. I haven't had a chance to finish this yet as much as you can, but I want to share some of the things I've learned and found so far in this progress of building this. So to kind of go back a little bit to the start, what the 1 billion row challenge is, this was something that was created only a couple of months ago, actually, by a fellow by the name of Gunnar Morling. And so the idea was to use Java to basically read through a 1 billion row text file and to do a whole bunch of processing on that to find out, you know, how fast can you make a Java application? How fast can it process stuff? Because Java isn't really known for being that fast. People came out with some awesome results. That's really great. The interesting thing from that, though, is people immediately looked at that and said, well, why couldn't we do this in other languages? It's a really interesting thought. So this kind of blew out into a whole bunch of other languages like Python, Rust, Node, etc., many, many different things. And that's kind of where this came from. To give a bit of an idea as to what kind of data gets processed in this challenge, you basically have weather data. So, for example, this morning in Melbourne, it was a nice, lovely 9.8 degrees, go Celsius. So from that, we have the weather station name, and there's 10,000 different possible names in the data set. And we also have the temperature, represented as a floating point number, anywhere between negative 99.9 to positive 99.9. And after going through all of these, the idea is to run a full calculation through this, and based on all the records to figure out for the weather stations, for each of the different weather stations in the data set, what was the minimum and the maximum temperature for each. And on top of that, also the average. Now, this is where it gets interesting because, of course, average isn't something just like a min or a max where you're doing one state to another. There's some running calculations. And I'm not going to run through the bits and pieces of this because we only have a limited amount of time. But in general, this would be easy if we just had one particular weather station. But in fact, we often have many, many different stations. Of course, 10,000 different weather stations, all the way up to 1 billion records. So there's a fair bit of data that requires processing in this. So how are some of the ways that people optimize this? Because I think for many of us who've done programming or computer science, you can kind of think through how this would work. But there's some optimizations that quite often pop up with this. Going through a couple, treating the floats as integers, because integers are a lot more computationally efficient. Reading them as binary and actually looking at the individual bits within the data, hashing and encoding the station names, writing custom parsers. Why do you need to parse numbers up to 65 trillion or whatever when you only need up to 100? Custom data structures to store the data, ripping out memory safety. Hey, why do you need memory safety if you just really want to go fast? And things like multi-threading as well. So there's a lot of cool stuff people can do here. But all this kind of comes into the realm of improving the application. So I kind of got the crackpot idea of why don't we improve the system around the application? Now, a common piece of feedback I hear about serverless is that serverless isn't good because it encourages people to write crappy code and just use the system to paper over the top of that. Now, many of us, I think we know that's not true. You have to have good quality code, but I kind of want to take this to the umpteenth degree. Could lazy code be made faster with serverless? So could I use some very lazy code to do this? And I've got a cat scratching at the door. Just bear with me half a second. You know better. All right, lovely. So that was kind of the genesis for this because I thought it would be interesting and a little bit clickbaity. So let's have a look through this and see how this turned out. The first thing I did here was coming up with a basic proof of concept. So I wanted to put together some code and run it on an EC2 instance. So I have a bit of a consistent baseline. Now, for this, I did a C7i X large because then it kind of runs with a similar specification to a large Lambda function. And this was good to get a baseline of performance. And the Tiger is the cat's name. She is very, very needy when she doesn't get attention. Now, to work it out this way, it took about 2 seconds to run through 1 million records, which is pretty good. If I take that up to 100 million, all of a sudden it takes just under 2 minutes. So scaling all right, but of course 1 billion is quite a bit more than that. So it took just over 14 minutes to run through. Now, this is good to give us that baseline, but this is also not serverless at all, and burn the heretic, we don't want to think about this. But we are going to keep those numbers just for reference. So, okay, let's throw this into a Lambda lift. Let's just throw the code in there and see what happens, right? So we have a very large chunky Lambda function with 8 gig worth of memory and 15-minute timeout. Now, unsurprisingly, the times were pretty much the same. A little bit of variation, but it was by and large the same thing. That's because this is horribly inefficient code. You don't really get any benefits, and this is kind of like a just-in-time server. This is where I think a lot of people kind of look at it and say serverless is no faster, right? And, well, of course, because I haven't done anything different. I've just run it on something different. So let's get a little bit more native with this. Next up, I thought, what about using one of those distributed map functions within step functions on AWS? Okay. Let's dig into this a little bit more. If we have a look at this, we'll have our step function there, and we'll have our distributed map, which has a nice 1 billion rows sitting in our S3 bucket. And for reference, a 1 billion row file tends to be about 15 gigabytes. So it'll go through and process all the different chunks in that, aggregate the results together to consolidate them all up. Seems to sound pretty okay. Let's see how this works. Now, this is a good way of using some native functionality, but we did hit a couple of hurdles when I went through this. The first thing was that it actually took quite a while even for the 1 million rows. And I think that was because it just took more time to actually read through the file before passing it into the processing. So in this case, this might have been a little excessive. It was trying to be a little bit too clever. But the problem I also found is that item reader can be fairly slow on a large file. Now, I could have tweaked the batching to be a lot cleverer with this, but in general, I found this was kind of not scaling the best. Because when I went to 100 million, it ended up taking a full 32 minutes. And about 20 minutes of that was spent just on it chunking out the files. So that was interesting. Now, the other part for this was that large files aren't exactly known for being great with this, because there's actually a limit with distributed map, which I never knew. I thought distributed map was just this magical thing you could just throw infinite stuff at. But part of item reader in step functions is that you can't actually process anything over 10 gigabytes or 100 million items. So this was a new thing I'd never actually heard of before as well. So in terms of that, this solution just can't do 1 billion items in terms of the way this works. Part of the challenge is that you can't pre-process the file and chunk it out in advance. It has to be a 1 billion row text file. So this kind of hit a bit of a wall with that. Again, I am very sure I could optimize this better, but that was the issue. So now I went back to my infrastructure stuff. And again, thinking like Walmsley here, it's kind of like, how can I make this just go really interesting if I take advantage of some of those low-level functions, some of those things I would think about from my system engineering days. And this is where block storage came into it, because block storage go brr. So In the start of it, we have this same basic logic. We want to take all the processing the chunks of the file and consolidating the results up. Now, the difference here is I want to split the chunks out myself. I want to write the code to actually start splitting it out. How's this going to work? Let's have a look. So block storage is great because it excels at really high throughput, really low latency, which is exactly what I need for this. I don't need something clever. I need something fast. So how does this look? We basically have an EFS file system attached to this, which is going to be used with all the different Lambda functions, which does mean you need a VPC just for storage because, oh my God, can we please get rid of this? I don't want to deal with a VPC. Anyway, looking a little bit into this though, if you're not familiar with how block storage works, a bit of a simplified way of looking at it is that you have all your bytes across your file and that they're all just tiny little chunks of a disk. And that normally you read from the start, you'll read all the way through to the end. But in this case, I might want to actually skip around that file. Just like on a CD, I might only want to read certain tracks on that CD from one part of the disk. So with the splitting, I basically got it to jump around. Let's say I want to do 128 chunks. Just jump about 128 of the way through the file, find the next line, chunk out how many bytes there are along the way, and basically get a whole bunch of indexes. From that, when we go through to process each of the chunks, we can just say, just read this part of the file. You don't need to read all the file, just this one little part of the file. You only need to read these bytes. This means it's very I/O specific, and it's very, very straightforward. So this becomes very interesting. And for 1 million records, we get 10 seconds, which is, again, not any faster, and in fact, quite a bit slower than our baseline. But the interesting thing is what happens when we scale this up. If we go up a little bit further here to 100 million, we end up with just 13 seconds. We're dealing with 100 times as much, but for only 3 extra seconds. Interesting. Now, what happens if we go all the way up to 1 billion? Turns out only 25 seconds to do 1 billion records. That's an interesting improvement, isn't it? Now, the curious thing with this is that the biggest limitation with this is actually the bottleneck in the consolidation. When I initially did this, I tried, what if I do 900 processing chunks? Like, let's just make this thing super parallelized. The thing that makes it slower is not actually how many chunks it's processing, it's actually the consolidation. Because if we're splitting out the chunks, that's a very low-level file system logic. It is very much just go to this part of the disk, look for this thing, get the index, pass it on. Simple. Processing the chunks, lots of small operations, very fast, very efficient. The consolidation where it has to read through and process all those different summaries, that's currently the slowest bit. So that was really interesting coming across that. Now, thinking about this, if we have 128 of those processing instances, which are running the 4 gig worth of memory, because that was just the amount I chose for this, we effectively have 0.5 terabyte worth of memory and 256 vCPUs thrown at the processing. So it's probably not too surprising that it's fast, which comes to the kind of the on-the-nose points for this, is that code plus lots of resources equals fast code. Shocking, I know. On the other hand of it, code plus parallel execution also equals fast code. Amazing. What happens if we take lots of resources and parallel execution? Then we get very, very fast code. Thank you, serverless. Now, that's kind of like the on-the-nose point, but I do want to go through some of the learnings in a little bit more detail, just as I've gone with this. The first thing here is you can't use serverless to bypass writing good code. And to be a little bit on point with this, while I didn't do a lot of the other optimizations that my brain is kind of like get low level and start thinking about the code, again, this was all Node.js and pretty crappy as well. Like I didn't optimize it very well, but I traded one type of complexity for another. If we think about that diagram from earlier, I haven't done any of the stuff in that improving the application. I spent all my time improving the system. And that's honestly taken me probably a lot longer than just improving the application. So that was interesting. The performance is determined by more than just the language. Again, this is Node.js. This is not exactly like I'm coding stuff in Rust and Go. It's very interesting. The compute costs won't hurt, like as Walmsley mentioned. Like I did the brilliant thing where I had a couple of iterations run where I had this 15 gigabyte file and I had some debug outputs on it. And yeah, thank you very much for that, nice $50 CloudWatch logs bill. So thank you, Community Builders Program, for sponsoring my stupidity. Now, there's plenty more I can explore there as well. And there are things like different ways of doing the processing and everything like that. But I really want to see what happens if I get 1 trillion records. Nobody's doing that. What happens if I go for that kind of insanity? How would I make that work? We'll see. So thank you very much for listening. Also, shoot through any questions in the chat, of course. And as one last shout out, because we do have Serverless Days coming up this week as well. That one's coming up next week in Sydney and Auckland. So Sydney on Tuesday, Auckland on Friday. Check out the link if you're interested in the agenda. And of course, a big shout out to one of our presenters here with us today, Michael Walmsley. So that's it for me on that. Thank you very much.
Great, Stephen. I was going to introduce the Serverless Days as well, so thank you for adding that slide. So next week, I wish I could go, but it's too far for me, and I don't know if I can time travel yet. So we'll see.
Absolutely.
When I can do that. Let me see if there are any questions. I see Aaron talking about temperatures a lot.
Everyone loves Celsius.
Yeah. So Maple has, I wonder how this would look for a byte range S3 get instead of using block storage in a VPC.
Yeah, and this was something I'd considered. I didn't go deeper into this one. My thoughts for this one were, because I am going for something that I wanted specifically to optimize for speed, block storage is pretty much always going to be faster than object storage. Just byte for byte, that tends to be the way that it works. You definitely could do this sort of thing using the byte range with S3. I kind of skipped over that as an option because I wanted to optimize for absolute speed. But again, maybe that is cutting myself short in things. The interesting thing is when I'm splitting out the file, the way that the file splitting logic works is basically to say, if I'm chopping it up into 128 bits, it basically gets the length of the file, divides it by 128, jumps ahead that chunk, looks ahead for the next new line, and plonks it out. The challenge with that is that then you kind of have 128 different operations to go get the file, have a look at it, find the next bit, jump ahead, that sort of thing. So I don't know if that would scale so well. Again, I haven't tried that yet, but that is a really good bit of insight. So maybe I need to dig further into that one as well.
Cool. Dancy asks if glue versus Lambda, which one is better?
Yeah, this was one of those ones where I was constantly fighting the whole thing of I could just use glue, I could just use Dynamo to store the data. So many things that could be done with this in more native ways. The trick with this one is I kind of went with the option of, again, in the spirit of the challenge, it's all about the code. I want to see what I could do with the most code native compute centric tooling, rather than just jumping straight to, hey, there's a service that can do this for me. So that was kind of the thing there. And even in thinking about the choice of this, my natural pull was, to say, let me do something like this in Rust, or let me do something like this even in C or something like that. My entire thing with this was, if I take code that is otherwise really bad and put it in serverless, does that make it good code? And it's like, no. Like, we already know this. Like, this is not a shocking revelation to any of us who've been dealing with serverless for a long time. This was kind of me trying to take that thing to the absolute extent for that. And I like that Walmsley's mentioned in there as well. AWS says there's a service for that.
They tend to do that, yeah. Yes. And a lot of times is what's best for your use case, or like maybe Michael, I have this issue sometimes, is what services are available for the region I'm at, right? If you're operating in the cloud or a less advanced region, right? So you have to deal with those limitations as well.
Very much. And I mean, thinking about stuff like when we're thinking about some of those things around the fact that I now have to have EFS, I have to have block storage attached to everything like that. This is a chunky as hell solution. Like, this is not a, this is not a very smoothly engineered solution in terms of that sort of thing. If I'm reading stuff consistently on, data trickling in over time, this would be a completely insane solution. For taking one big file that's appeared out of the blue and processing it as fast as humanly possible, that works kind of all right. So this was one of those, oh, there goes my background. It's one of those things of trying to figure out what makes the most sense in that particular scenario. And yeah, so it was also mentioned like elastic map reduce. There's a whole bunch of things that can be done if you needed to do this in that sort of thing in production sense. This was a bit of a case of, if I take serverless and just beat it over the head with a big stick, it's like, how can I make it do something that it's really not meant to do to find some of those edges? Like the fact for distributed map. Like the fact I found a case with distributed map where it's like, I didn't really think there was an edge to that, but apparently there is. And there are other ways around that too. But this was one of those things I kind of discovered throughout the process. Again, this is why you get out there and build stuff, because it's just like, I never thought of that being a problem.
Yep. Cool. A lot of good stuff. Last question I'll take here is from Maple. If you have a repo where you have this visible for anybody?
So I don't have a repo as yet. Right now, it's sitting just on my local machine. And again, the history of it is just, it's terrible. It's awful. It is something I am going to publish as I get towards just saying, excellent, this is now in a state where I actually feel comfortable putting this in front of other human beings. But that is kind of the next state of this. I do want to get this to the point where I can actually share that around, specifically for this, also to see what other people might want to build from it as well, or to take from that. So at the moment, it's not out there yet, but it will be, so watch this space.
Cool. Thanks a lot, Stephen. So
excellent.
I guess we'll wrap it up. Can we bring everybody on the screen?
Come on, is they gonna go? Oh man, they're not going. There we go. Yeah.
Oh, you got some fancy setup there. Yeah, so don't forget about Serverless Days. Thank you to all the speakers today. This was awesome. I think it went well for our first one of lightning rounds. I do want to plug more BIS, Believe in Serverless talk. So we have Jamie Dalkis on Thursday talking about a cloud grill delights, a high-tech approach to a perfect barbecue. And on Friday, I'm going to skip Allen and I'm going to be live coding with Benjamin Pyle, where we're going to try out AppSync and build a GraphQL API for pizza ordering. The theme is Ninja Turtles, so it should be exciting. So again, thank you everybody, and hope you have a great rest of your day, and I'm probably going to go to bed soon. We're in completely different time zones, so thanks a lot.
I'm going